So I'm going to try and get through quite a lot here. So it's going to be a whistle-stop tour of what it's like to learn to code using your eyes. We're going to start with a very basic introduction to what does it mean, what is eye gaze, how does it work. Some of what you're going to see is going to make you think that an eye gaze user is a mouse user, so we're going to explore the limits of viewing it as mouse-only control. We're going to explore what happens if you actually can't control a mouse with your eyes, if your eye gaze setup or your experience level is not good enough to do that. How do you access block-based coding? And then end looking to the future with something new that I'm building to plug some of the gaps that I've identified in this project. So eye gaze is the name that we give to the human-computer interaction paradigm of controlling a computer with your eyes. To do this, you will need a piece of hardware called an eye tracker. This might be something you plug into the USB port of your computer. It might be something that's already attached in a bespoke all-in-one unit. Some people try to do it with webcam. Apple these days on iPad kind of does it with the front-facing camera, but it's rubbish. So it's possibly slightly better than webcams, but not good enough. If you want to do eye gaze, you need some hardware. Once you've got the hardware, you know approximately where the user is looking on the screen. What do you do with that information? So here there is a grid of words on a communication device, and each grid is a square that you look at, and a timer comes up for a certain amount of time, typically about a second, to convert just from I know the user is looking there to the intention of I know the user wants to click. And that's a communication device that a lot of people might use if they have something like cerebral palsy that means they can't speak with their mouth. You can also use your eyes kind of like a mouse. So this is iOS iPad eye tracking in Scratch. So the person is looking around and a blob is following their eyes. When they look in one place, they get a very subtle timer to perform an operation. Let's see if I can show you that again really quickly. And so you point, you click, you tell it that you want to do a drag, you point, you click, and you move it to the location that you want. This is an example on Windows with a different kind of eye tracker where you say, I want to do a left click. You can see a tiny little dot moving around, and then a large zoom area comes up so that you can precisely click on what you want. So you can click through the toolbox of MakeCode and select a block to drag. You'll notice the little blue dot darting all around the place. That is not just estimation noise, that is truth. Our eyes evolved as a sensor to view the world. We have really high resolution in the center of our image. So to actually see everything, we have to dart our eyes all over the place. So part of learning eye gaze is learning to take what was originally a sensor and use it as an actuator. That is hard, and all of those examples were from experienced users. So where does this work well for block-based coding? Well, actually, block-based coding was designed from the start for pointer control, whether that's mouse control or touch. So the paradigms map very naturally. It's really direct. Sometimes when we ask users to use assistive tech to operate an interface, they have to learn an indirect mapping from what they can do and how that works in the interface, whereas this is just point and click. You want to move a block, you look at it, you move it, you click on it. And what's great, for some people who have this level of eye gaze control, no interface changes are needed. So this means you get equity and you get all of the benefits that Rachel was talking about earlier of collaboration. If everyone in the classroom is using the same interface, someone's using a finger to touch and someone's using their eyes, it looks the same. If you don't know how to do it, you ask somebody how they do it, and you can do the software mapping of how exactly do I do that in eye gaze, because the UX paradigm is the same. There are limits to this. A big one is just that it's hard, and it can be not as accurate as you would like, and it can be exhausting. But to give a few examples in a very brief talk, dragging is difficult. You have to keep that intention of I am using my eyes to control a thing. You have to keep that going for much longer than a single click. So you click on one location to start a drag, and you click on another location to end a drag, and look, it didn't work. Because in this case, the user did not have visual feedback as they were doing the drag, so they clicked right in the middle of the target oval, which isn't where you need to put it, because you need the connections to line up. It is also the case, as was mentioned earlier, that dragging a single block can be quite hard. So this user wants to move the block right with shadow down 2 spaces into the if block. They've done this before. They know that they have to be a bit clever and kind of separate things before they do that. So they bring it out to the workspace, and then they try to drag this block down. Again, in this mode, the eye gaze software doesn't give a live preview of where the block is going, so the entire stack just bumps out the way. And eventually, with a number of drag operations, they get what they want. But when every single drag operation is expensive, this is exhausting. And it would be a massive context switch to pull up a keyboard and hold down Alt, and it might not even work depending on how your keyboard emulation is working. So where does this go wrong? I've just shown you drag being difficult. You'll have seen in the videos as well, there's a whole lot of mode switching. When an eye gaze user is using a piece of software, they want to stick to click, 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 or maybe, if they're comfortable dragging, drag, 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 drag. Every time they switch from clicking to dragging, or now I need a right click, that's a cognitive cost. And then you get these cascading failures. So if your drag is a bit inaccurate, or your eyes are getting tired, and halfway through a drag you put the block in the wrong place, suddenly now it's in the middle of a stack, and to move that you then have to do this massive rearranging. And yes, undo exists, but that's another mode switch. In Scratch, that means switching to right-clicking, switching to left-click, undo. And yeah, it can go wrong quite quickly. So far, I've been assuming that you are a mouse user as an eye gaze user. And that is generally the case from kind of a couple of years into secondary school onwards. People are trying to do mouse control. Even if it's hard, they want that directness. But at primary school, users don't yet have that level of accuracy in their eye gaze system and practice. So they might use a grid that looks a bit like the communication device. So here you can see an embedded browser with microbit makecode in the middle. You've got 12 buttons around the edge, which are large targets, so you don't need to be super accurate with what you're doing. You look at a target for a left arrow, down arrow, right arrow, enter, and you use what is now the keyboard navigation within makecode to do everything that you want to do. And this is possible. It does require some nested subpages to get everything that you need access to. I took this to a primary school, so I'd done a bunch of Zoom sessions with a wide variety of people, and then I went to a primary school in person and worked with 2 individuals. And the speech and language therapy assistant who supported me there said, this has given the students confidence to try new things on their eye gaze accessible computers, which they did not have the confidence to try before. The students are now also aware that coding is for everyone, no matter their access needs. So I could have ended here and celebrated that, but that would have been dishonest. Because I think, having left the room, that's not going to get used by anybody else. Why? Because there are so many competing cognitive demands in the room. When I went in there, I had to introduce, this is a microbit, this is what it can do. I had to tell them what we are doing today with the microbit. We are writing a program to make a thing happen. What is a program? I get out my magnetic blocks and I explain the basics of how code works. And this is the makecode interface. How does the interface work? This is the toolbox, this is the code. This is all common across all kids learning block-based coding. This isn't new, but what's different is that when you scaffold all of this to a large classroom, you already believe that your students will be able to get to the end point. There is a massive problem with low expectations in special education, and there's a massive problem with access barriers that might appear later in the process. And not only that, we're adding several new layers here. Because of the indirectness of keyboard navigation, we're saying you have to really understand how the interface works. How do you navigate it with your assistive tech setup? Maybe what page are you on in your interface? Where is your focus right now? What actions are available now? If at any point a student goes away and tries to work more on their program when I'm not there, they could have a gap in understanding of any of these, and there are no adults around them with the skills and knowledge to help solve that. So I went back to basics and pivoted on what I said I'd be doing for my Blockly funded project and started building what I would do, that's a shame, if I started from scratch. So using Steve Jobs' approach of start with the customer experience and work backwards to the technology. Oh no, these ones are more important, those ones weren't. It'll be fine. So I have identified 2 very disjoint user groups that encapsulate my eye gaze users, but also, I believe, include users of different assistive tech. So on the one side, you've got mouse users. So the design constraint here is we want single click only. This would also be useful for somebody using a head mouse, maybe with a switch or a dwell to do a click, a joystick with a single switch input. So we don't want drag to be required, single click only. For grid users, you could be using eye gaze, you could be using switch in a grid-based, switch access to a grid-based interface. And the problem here is the scaffolding of all of the things that you need to learn. So we focus on learning the task before the navigation. The rest of the videos, I'm hoping. So this is what it looks like with mouse control. Everything is a single click. So if you want a block from the toolbox, you just click on it. It goes into the place in the same place it would go in the code as if you were doing keyboard navigation. So you have the same heuristics, which in a simple environment where you're building a single stack of blocks seems to work better than I thought that it would. If you want to move a block, this is the same video again, you click a block that's already focused and it shows you all of the connections you could move it to, and you click again. Some people actually, at a certain point, prefer drag. If drag is working, you can switch between that. But if drag doesn't work for you, you can just do single click. And then you also don't have to worry about things like accidentally smudging the screen. For grid users, we start really, really basic. We don't want anything to go wrong at the beginning. So this is just a game. This is not coding, you might have noticed. You are just using a grid interface that you're familiar with, and you are playing a game, and you can't get it wrong. You're moving a character around a maze with moving forward and turn left and right blocks, actions, which will map onto blocks later. We then introduce the concept of coding, but still with very little opportunity to make mistakes. So you're still just directly controlling a character. If your parent comes along and helps you out with the maze, they don't get scared off by the code, because the code is incidental. It's building a program as you go, but it is immediately evaluating each block as you go. You're not having to do the mental projection yet. There's a couple more stages that I won't show you, but eventually this builds up to full toolbox control. So this is very much like what I showed you with MakeCode, but everything is a single interface. There's no nesting of interfaces here. So you have large grid cells to target for keyboard actions. You jump to the toolbox. You use arrow keys to select a block. You press enter to insert. Insertion is immediate rather than putting it into block mode, because in this simplified situation, that is usually what you want. And then you run your program. So everything is accessible with large targets. You don't need any mouse control at all. And that, although it's a simplified environment, that kind of navigation could then map to MakeCode, where you have to learn, or Scratch, or any of these platforms, now that everyone's adding keyboard control, without having to learn all of the other concepts. So in summary, I have very quickly told you that an eye gaze user is sometimes a mouse-only user, and the only part is important. Once you're in mouse paradigm, you're not going to want to leave it to go find an on-screen keyboard or anything. Sometimes they're not. If they're not a mouse user, they're an indirect keyboard user, and they're very rarely both of those things. As soon as somebody gets a taste of direct control, that's what they want to work. So go away and think about the cost of mode switching in UX, and think about the cost of indirect navigation when direct navigation is available. Coding with mainstream platforms is possible, but with caveats. We should celebrate that we can already do this. And I'm building a new platform designed for these two user interaction modalities. Please talk to me, email me, whatever, to find out more, or try it out if you've got any users. You can get my website on the QR code. We probably don't have time for questions.
We have time for one quick question. Any question? Yeah.
Hi, I'm Philip. If we were to, do you have a recommendation for eye gazing tool, I guess? Or?
Tobii eye trackers are typically the best. They're quite expensive, but they're worth using, yeah. Thank you.